and y equals x squared, and rotate it from the x. Alright, so we're going to do more problems today, so this is not the only one. We'll continue, but number 1 and number 2, those were about rotation, about the x-axis, right?
Mr. Myers, we don't call off of screen. Mr. Myers,
let's take a look and we'll continue with problem number 3. Here we have to rotate about the y-axis. So we have y equals x cubed, then we have y equals 8, x equals 0. So now remember, these are the curves that we have to work with. So we are rotating the area that is enclosed by these curves. And as I said, we're rotating this about the y-axis.
That's our team building
right?
it.
Now you can put the picture into your calculator. I mean, just use your calculator to see what that is. Now the other thing is, you know, the curve or the line x equals 0 is what? What is x?
Third of my
X equals 0 is?
third of my unit 2 test. Transformations.
Y-axis, right?
Up, down, left, right.
So this one we're not
Cross
going to
vertical,
graph,
cross
okay?
horizontal.
This one we're not going to
Vertical.
graph. But everything else we can put in the picture, okay? So let's say we have x cubed,
Normal
just to see what we have. I know these functions are easy to know, but when we graph, and that thing's warming up, so
and we're hoping to get
this is what we have.
That'll help.
And now remember, you may have a little bit extra of the picture, right, on the screen. So not everything that you see will on the wall. But look over here. We're talking about x cubed, and we have this curve right here. Then we have y equals 8. That's the horizontal line. So keep in mind, y equals 8 is not just a point. Right? It's a line.
Yeah, we kind of did it on
our
our
x
own.
equals 0, so this is what we have for our picture. Just this little area right here. So not everything that we see on the screen we're going to involve. Just tiny area right here. And we're going to rotate that area
because they'll be fine.
about the
the ones that are
y-axis.
fine now. The
So
ones
we have
that
this
are
little, let's say 8 is over here. It doesn't have to be precise, but you still have to see the picture. Let's say this is 8.
Hadley already moved.
This is the curve. Let me switch to the screen, and we can see.
He's a past test.
And
Greg hasn't passed the test?
this is what we have.
Wow.
So this is the area that we're supposed to rotate. Do you have any questions about the area?
He doesn't do it so much.
Okay, so we're rotating this area, and again, our axis of rotation is the y-axis. So when we rotate, we'll just get this picture right here, and this thing's gonna look like this.
He's an honor.
Well, kind of not exactly, but yeah, if you think about the shape, but this is what we have. So that's the shape that we have. Now, the other thing is we have to remember that we need to slice this, right? And not mainly we're going to create a lot of cylinders. We kind of got the idea, we know it's the integral. But I need to know the radius, because again, if you go back to the formula for the volume, it was integral from a to b, then we had this a of x dx.
There's some kids who
And
ended
a
up
of x here is the area of the cross section. Well, mainly for all of those, our examples are the same.
Some of these kids.
Today and tomorrow
Like this should,
and overall.
this should be an honor.
We're talking about rotations, right? So mainly we'll have circles as the cross section, but formula is not saying
Oh, this is my
always you will have a circle.
This
Remember I
kid-
talked to you about this last time.
Yes.
You may have something like a prism or something else.
You know,
The main thing here is when you
I do
slice,
too.
you will be consistent.
Well, I have these.
Consistent with the shape. So if I choose to keep slicing over here, no matter what, I still have a circle.
Yeah, he
Right?
never shows
That's
up
what I'm saying.
yeah, that's the same
So,
last year.
I don't know, right here, let's say I'm going to
This is
slice
my
this,
saving grace.
and
Sir.
I will
This is my
have this
regular class.
circle.
This is
Now,
my,
as
so
I said this to you last time, hopefully, maybe
Awesome.
not.
My
Well,
next two?
let's say
No.
I didn't say this. Well, if you're getting a circle
I don't
here,
have anybody.
We call it a disc,
Anyway, this is a top class.
right?
I have,
So, also, what did you rotate? You rotate the area, right? Right here.
Yeah, well, I
This
was
is what
just
you rotated. You rotated the area. So this would be solid piece, okay? There's no
Don't tell them it's the box.
whole inside row empty. This is the solid piece. So the next thing is, what do I have to determine? I need to know the
Okay,
radius
so
of
graph
this
again.
cross section. So I
Okay.
have to go from
So,
axis of rotation
This class
to the
actually
original
was
curve,
passing it.
not to the left, but to the right. So the question is right here, what
This is
will
like
be the
the
distance
worst
from
one?
here to right here?
After class is done.
And then it gets worse from there.
It's the same.
Okay,
You have
well,
no
you
age
told me
difference.
exactly
Who
what
are your
the
kids?
function, how the function is. But in reality, it's not x cubed, it's what?
Right, curvature.
It's cube root of y.
Yes, I
Because
was
remember, it's a horizontal distance, not the
Beatrice
what?
is just so much
Vertical
slower.
distance. So you're right, we'll go to the curve. But one thing you have to be very careful to know what you have here.
He's too smart.
So this distance is not x cubed. This distance as my radius is y to 1/3.
So
So,
see who else. Jesse.
So the next question, are we going to suffer like this, like not knowing if this is x equals or y equals? Well, the answer is no.
Okay.
And I'll give you the shortcut, quick
so
shortcut, very
yeah,
nice and simple.
it's.
So go back to number 1 and 2.
I don't know what.
So we were rotating those
Did you-
about what? X-axis, right? And that was what? D.
No.
He needs to
X.
go.
Now you're
She's
rotating
okay.
this about what?
He's
Y-axis. So
not
that
doing
means it's
anything.
D,
She's.
Y. And if it's dy now, it's easy. Everything has to be x equal.
Well, she's not going to be.
You see what I'm saying? So you don't have to worry about this, like, what really is this? Well, if you know it's dy, then automatically you know it has to be in terms of y. And then we shouldn't have that problem. We'll practice more of this, okay? But that's what we have. Maybe I can add even more, and I want you really to remember this, so maybe write this down. If we are rotating about the
Or
y,
she
so
could because she knows what
x-axis,
the heck's going
on
on.
any
Or she
line
should.
that is parallel,
So,
to
and
x-axis,
she says, I'm
it's
just barely
always
hanging on.
dx.
What do I do?
okay, so one more time.
And
If
then
you're rotating
this one,
about the x-axis,
Mason,
and any line that parallel to
and
x-axis,
Mason,
it's always
Mason,
dx.
I can't get him to do it.
If you're rotating about the y-axis, and any line that is parallel
Oh, that's a bit
to y-axis, then you have what?
George.
George.
George, I think.
What do we have? dy. So get this as a rule, and then it's easy, okay? You won't have any problem to follow this. So,
Riley's mine.
now what do I have? I need to know this thing of x, but in
Yeah,
reality,
he's gotta
I'm
spend
looking
it
for
because
a.
he's gotta do
I'm
something
looking for
else.
a of
Okay.
So somebody's coming.
y. Okay, so being a little bit more specific.
I only had 2 of those kids.
Now, I hope we're not going to argue like
Oh, Mason, I
why
had
the
Mason.
formula we
So
have
three.
a of
Three of my
x,
kids are
well,
passing.
the way we're
That makes me
rotating
happy.
was dx,
Did you
right?
have Gracie last time?
So that's why we have a
Mason.
of x, but now you're rotating about y-axis, so it's
Okay.
y. So we have a of y.
Yeah.
So the formula is still the same. You go with the radius, right? And then you take what? Y to 1/3 as your radius
You
and
had who?
square.
So we just have to send a note.
Barely passed.
And
I don't
we
have
have
that George.
pi
Nope, doesn't like George.
y
George
to
Center.
2/3.
Barely passed.
So that's it. I mean, that was it. So there's nothing difficult if you understand the concept, except really careful choose if it's dx
Oh,
or y,
and
and then you know what to
Jen
do.
called me and said,
So
I
So
can't
the volume here
I can't
will be,
move
we can take this
anybody
pi outside,
in your second hour because that's when seminar
and
is.
I'm going to put this
And I
y
said,
to
I
2/3
thought you were gonna
dy.
move some
But
classes
then
around so that
from
you
what
could
to
be in
what?
there.
What is your lower
Was
limit?
that like Mason?
Mason and my other young
0,
lady.
right? That's right here.
Um,
And
Joanna.
to 8. Absolutely right.
That's up to them. I know,
Basically,
like Ivan
it's
has
the height,
been moved
right,
in as of a
Of the
while
shape that
ago.
you have.
So-
Well, she called and she said she wouldn't move them because they had second hour.
Well, very
I'm not
simple
taking out their math
integral to
class.
work
And it's
with.
like,
So we
can't
get
you put
pi,
them into a different hour?
and then we get what?
Well, looks kind of hard.
3/5, right? Yes, no?
So I'm
Well,
not
I-
going to have
I-
any
Y
more
to
students.
What's that?
Item needs to be moved.
5/3
So
from 0.
that's my second hour. That's actually my better class. Here's my fifth hour.
And Sparkle.
Taylor's mine.
And then we substitute. So we get pi 3/5 times by 8
Will is
to
mine.
5/3
There's nothing.
minus
I told you
2
that
with
from the
0.
get-go.
This is
Oh,
just
that's
0.
his parents
So
like
what do
once.
we get as the
Joey.
answer here?
Joey.
He
He's-
just won't talk.
Well,
Just
he's the one I
substitute
tried to
quickly
get
into
to
your
go
calculus
to
and get
Seminar.
96
He
pi,
was
right?
tried,
Don't forget that pi
but he
is
doesn't have a clue how
over
to do it.
5.
So
He was always by Robert and Beto last year for a lot of it. And he had them.
So-
You
Somebody
can
asked
check if
for
you're doing
the
it
others.
right, but you have to understand you only check it for right. if you're getting your integral right, yes?
Oh, nobody likes
With
her.
the calculus. But not necessarily you will not be
No
doing
kids
this
coming
right
in.
from the
Like
beginning
7
as a
hours.
setup. So that's
Half my
very
class is
important that you have all these pieces right, like your radius
I
and
had
all that
record.
to put
I
in.
had D
The
for
rest you
half
can just
the-
take this, put into calculus and see if you get
Well, I know
this
why
number.
third
And just the
one's
process of integration. But your calculus can do more than that.
A minus kid
You are setting up
He
the
has
whole
done
thing. You're
no
going through the
homework since the
process.
beginning of the
And
year.
then all your calculus
His
will
mom
be
would
useful just to
I
check
did.
if you have the
I
number
emailed
right.
Mom.
The other thing is,
So then
if you
she
check
didn't
in
back
this
it
for the
off.
calculator, for
No,
example,
she said it's good to know.
don't put pi into it. So just check this, and then
That's
just
Cody,
use
who's
pi.
in the honors class. That's his little brother, Spencer.
On the desk.
Shouldn't be in a.
But Brandon wasn't brilliant. You got to remember there was a difference between the brothers.
Yes, no.
Well, have fun,
Difference
good
between
times.
brothers. Yeah.
I'm leaving.
Very
I
much
gotta
so.
go over and talk to them.
Not much in my family.
All right,
I was one of the idiots. in
let's
my family.
continue with this.
Can you see us all leaving?
Yeah, ish.
All right, so we have the next one for that one will be a little bit more complicated. So from now on, kind of we're pushing more difficult problems, and where really difficulty will come from is the axis of rotation. Okay, so these three examples we had rotations about x-axis, right? And we had rotation about the y-axis. Now we're going to change axis of rotation. That's where difficulty will come in. What do you say? Oh, okay, I thought you were trying to say something that I want to listen to.
I don't know if that was such a comes never the case.
Well, so we have the same, we have y equals x and y equals x squared. We already had this before, okay? But this time, we're going to rotate this about y equals 2. Alright? So let's just talk about this before even you do anything, because this is important, dx or dy. Yeah. So how do we know?
It's a line parallel.
Right, y equals 2. Now don't look just at y, right? See how it goes. Y equals 2 is a horizontal line. It's parallel to the x-axis, right? So we have what? dx, okay? We know beforehand that we have dx. So what that means, I don't have to I don't have to do anything with these functions. They're okay for me. I don't have to change them to x equals. The next thing, we're going to sketch the graph, okay? And remember, we already have this picture, so we shouldn't have any problem to recognize what to do. But if you still want to graph, that's fine. Put x squared. Oop, I don't need that. I don't need that. Going back to this one. And putting x squared. And when we graph, we'll get this. Okay, we've seen this before. I'm going to zoom in just to make sure it's a little bit easier to look at and better to look at. So we know we're going to rotate a little piece, yes or no? Right? We're going to rotate the little piece, but you're going to rotate this about y equals 2, so give yourself some room that you can move picture out. Do you understand that? And you have to be very careful when you will be doing this on the exam. Again, I really don't care what Web Assign does, and I kind of not very supportive in those 4 pictures that they give you, but there's no other way to do this, okay? But make sure you know what to do on the paper. Because I see students, they understand how to do the setup maybe, but they just can't put the picture because every time they rely on WebAssign. So please, again, be careful with WebAssign. It's a great tool, but sometimes we have to be kind of on the edge and thinking about, like, is that what I want to do? Maybe I should just do this on the paper. So I have this. And I'm rotating this about y equals 2. So here's your axis of rotation, y equals 2. We're okay with this? Right? So when the picture goes, you see I try to give myself enough room, but sometimes maybe that will not work. So don't be afraid to erase this on the picture. But something like this, right?
Oh boy.
Do you understand? And don't forget, you're rotating the original one that sits on the bottom, and that's where this is the piece that you're working with. So, if you slice this, right? If you slice this, so you'll get the washer, right? Well, we said this before solid, right? Now you get the washer, okay? So basically, and I don't know if I put this in the right way, but what we're creating here, we're creating something like this. And again, normally I'm not doing this because I hate to do these kind of pictures, but basically this is what you have, right? I'm just going to move it to the right, just to make sure you see it. But overall, it's somewhere over here, right? Overall, it's somewhere over here. And normally, and again, if you look at what was signed, they're very creative there. You know, they're putting this beautiful picture and all that. Well, I know you cannot do this. So probably the best is just to realize that you have a cross-section right here, right? And as the picture, you'll get this washer over here. So when we go with the washer, which we had before, right? We go with the washer, we need to know area of the largest circle minus what? Area of the smaller one, right? And what determines those areas? The radiuses, right? So you need to know the radius. So basically what you're talking about, the distance from the axis of rotation, it's always going from the axis of rotation to the outside, right? So what's the distance from here to right here? Or if I say from here to right here, distance to the outside, what will be the distance?
It would be 2 minus x squared.
Okay, I put a question mark to that. Is it true or not? 2 minus x squared.
We're talking about the inner part.
No, just outside. We're talking about from here to here. Outside. You go with that? 2 minus x squared? And that's the right answer. Good. Yes. It kind of, you know, this idea of, we're kind of almost using geometry here, okay? Putting these distances, okay, together. I think I mentioned this like segment addition postulate maybe last time, maybe not. Did I say anything about that geometry thing? But, I mean, I don't have to, but I want to make sure you understand. You know, like in geometry, you learn, this was the beginning, by the way, geometry. It was like A and B and C. Did I do this last time? Probably not, because you look surprised. I don't know. But remember how, like, what is AB? AC plus what? CB, right? The next question, like, what is AC? It's A what?
AB minus CB.
Minus CB, right? Well, that's exactly what you just did. If I separate this, you see you have this piece and you have this little piece on the bottom. You understand that? So we did what? The whole thing minus that piece. Okay, that's the whole idea here. So, speaking about radius of the larger circle, R sub L, radius of the larger one, you told me what? 2 minus what? X squared, right? So this will be 2 minus x squared. Then speaking about radius of the smaller circle, then what do we get? That's distance from here to right here.
2 minus x.
It's still 2 minus x, that's right. When you get this part, I can guarantee that this is 80% of your success. Okay, then you can understand how to get those radiuses. Well, the right way to say radii, but it's not bad. I'm going to go radiuses here. Well, I probably should finish this thing. And we have CB, what will be CB? AB minus what?
AC.
AC. Well, that's just to understand how we look at the picture. But that's important. Do you have any questions about why 2 minus x squared and why 2 minus x? Doing okay with this? And I'll give you more examples, okay? But you really have to practice, you really have to see this. And that's important. That's where the biggest failure comes in. Not knowing how to find radiuses. So, now what I'm doing here, I'm setting up my A of x. Remember, that's cross-section. So I'll go with the largest circle. So we get pi 2 minus x squared quantity squared. So that's the area of the larger. Minus pi 2 minus x quantity squared, and that's the area of the small. And that's how you get your area of the cross-section. Any questions about this? Area of the larger minus area of the small. Okay? And one thing, I think I mentioned this last time, maybe yes, maybe no. The concept came from the areas, right? Area of the larger minus area of the smaller. Not radius of a larger minus radius of the smaller, right? First find area and then subtract. That's what we talked about. So if you'd like, for example, you can simplify this right now. You can simplify this whole thing, factor out pi, then open parentheses, combine like terms, and then put this into the integral. You understand? Or you can take this whole thing and put it into integral right now. Normally I just put it in, but I'm giving you a choice. You can simplify, put it in, then do it. Here I'm going to pull out pi. Integral, question, from what to what? Don't forget this is dx. So dx means what? How tall it's on x-axis, right? So that's 0 to 1. That's what we have, from 0 to 1. So integral from 0 to 1, and I'll use brackets or parentheses, doesn't make a difference, just to make sure it's put in the right way. Alright, so that's the setup. So I will say this again. The most difficult part of this problem is to get the right radius. The rest, there's nothing difficult. So let's open parentheses. I don't know if I have to keep brackets or parentheses. Remember, those are grouping symbols, so it doesn't make a difference. But what do we have here if we open parentheses? 4, right? Then what? Minus 4x squared, good. All right, and here we're going to do 2 steps. We're going to FOIL this and then open parentheses at the same time, because too much to write. Minus 4, right? Then what? Plus 4x, right? Good. Minus x squared. Good. And I'll put the bracket closed. Now I'm going to switch to parentheses. All right, so 4 and 4 will be canceled. That's good news. X to the 4th, I'm just going to keep it because it's positive first, so it goes first. Minus what? Minus 5x squared, right? And plus 4x dx. So that's our integral. Very simple antiderivative. So we have x to the 5th over 5 minus 5x cubed over what? Over 3 plus, what do we get here?
2x squared.
2x squared, that's right. And from 0 to 1. So it's nice to have that 0, okay? Well, I cannot guarantee that all the time we'll have 0. It depends how the picture looks like. But it's nice to have. So we'll get pi, and then we'll get 1 over 5 minus 5 over 3 plus 2. And minus 0, right? If we put 0 the whole thing. So putting this into the calculator, we'll have a pi over 15.
That's not as bad as I thought it would be.
It's not that difficult. Now, the main thing, I'm just giving you the idea, okay? But you may have some little different functions, but overall, it doesn't make any difference. If it's smaller, or maybe sine instead of x squared overall. Because you still can get antiderivative easily, okay? Except we're just still looking at the picture and trying to determine the radius. That's the main thing. So, and again, you should practice. Again, don't just kind of rely on what I told you here. It's very difficult, especially if you will not go through the process of doing this on your own. Going to the next one, let's go to 5. We'll still have the same curves. I know you're saying why the same, because I want you just to see the difference, how everything will be changing if you just change the axis of rotation. So we have y equals x, y equals x squared. And we're rotating this about x equals negative 1. So let me ask the question. Dx or dy? It will be dy. And that means what? Every function that I have, I must change to x equals, right? Because I must have y as the variable. Well, this one is easy. And here, what is x?
Plus or minus square root.
Right, we're going to keep it plus or minus square root of y, but when we start graphing this, we're going to see what we need, what we do not need. Now, by the way, remember, when we graph these functions, okay, because it's y equals. But when we start working with the integral, we're going to use these, because we're switching the variable. So you know the picture, okay, so that's not the problem. One thing I'm going to tell you, since you're rotating this about x equals negative 1, push this y-axis a little bit to the right. And you have some room to rotate over here. So, picture again, this is just a sketch, so here you go. This is the picture. This is 1, this is 0. We have this picture, but I'm rotating this about x equals negative 1. So here's my axis of rotation, so it's x equals negative 1. So if I rotate this, again, it's just a sketch. This is what I will get. All right? And remember, this is the original one right here. So, the next question that I have, let's talk about the radiuses, radii. So, radius for the larger circle. Can you tell me, and I'll give you a couple seconds, okay, because I want everybody to think through. What is the radius for the larger circle? And keep in mind this is dy, okay? So don't forget.
Is it x squared plus 1?
Now, remember what I just said.
Alright.
Keep in mind that this is what? dy. So think about it in those terms.
Oh. Square root of y plus 1?
So what do you think?
Yeah.
So you are over here, right? You're over here, but somehow you have to get to it, to this point, right? So if you look at the picture, now, one thing, what I want you to remember, from here to over here, that's just a curve, right? And here, from here to here is what? It's 1. So that's right. So we have 1 plus square root of y. Do you understand? Yes, no, over. Yep. So 1 plus square root of y. Now, remember we're talking about distance, and here this can be confusing. Well, I see you didn't have any problem with this, but many students will think about this as negative 1, right? But don't think about negative 1 because it's just a distance, right? Like absolute value kind of concept, right? Distance from 0. So it's not negative 1 distance, right? Distance is just what? 1. So from here to here is just 1 unit. And then plus the function, right? Just so what about now the smaller circle?
1 plus 5.
So this, the same idea, right? From here to right here. From here to right here. So this will be just 1 plus y. That's right. And if you give this, I can tell you the rest will not be that different. Do you understand the radiuses? Radii? It's easy to say radiuses. Any questions? I will get them. So now what do we have to do? Now we have to put a of y, right? That piece. So we'll have pi. Area of the largest circle will be 1 plus square root of y, quantity squared. That's the area of the larger one. And again, we have a washer here. Yes, no? Yeah. Okay, I'm just not graphing it, but if you rotate, you know you have a washer. Minus pi And area for the smaller circle will be 1 plus y squared. Well, that's all we need, so let's do it again. Put into the volume, so pi goes outside. Now the question, integral from what to what? Now remember, this is dy, right? So you want to see how tall this shape is on your y-axis. So, yeah, this point over here is 1, 1, so this will be from 0 to 1. Okay, so from 0 to 1, and again I'll put brackets here, 1 plus, I'll change this to 1 over 2 power. And then we're going to subtract 1 plus y, 1 squared dy. Well, right now it's more like mechanical work right now, just finding integral. So pi, integral from 0 to 1, I'll probably start putting parentheses because I'm opening inside parentheses, so we get 1 plus 2y to 1 over 2 plus what? Y, good. And then I will open a parentheses and times by negative. So minus 1 minus 2y and minus y squared and dy. So let's combine like terms. So 1 and 1 will be cancelled, and everything else has a negative sign. So I'm going to keep 2y to 1 over 2 first. Then I'll have minus what?
Minus y squared.
If you want to put it that way, that's fine. And minus what?
Y.
Minus y, good, dy. All right, so we simplified. Now we have simple power function inside of power functions. So when we go with antiderivative, what do we get here? What will be the first one?
4 over 3.
So 4/3, good, y to what?
3 over 2.
3 halves minus y cubed over 3 minus y squared over 2, right? This whole thing goes from 0 to 1. Okay, I'm going to try to fit this on the paper here. So we get 4/3 minus 1/3 minus 1 over 2 minus 0 again, because we have 0, not because I want to have 0. And what do we get here? Quickly, I just want to make sure I have everything right, because I have just the answer and work on it. So what do we get here? 5 over 2? Okay. 5 over 2. Got the idea? What's happening when we shift? And you will be working with this, and you have to kind of pay attention to every step. So now I'm going to put, and I don't know if you're starting doing 6.2. I don't know if you started or not from last time, from Friday. But I'm just going to pick one example, not necessarily from homework, but for one of those that you have on your homework assignment. So on your homework assignment, you have some problems. For all of them, you have only one picture. I don't know if you looked or not, but they will give you something like this. This is 0. Here we'll have point C, 0, 1. Right here you will have A, 1, 0. And here you have B, 1, 1. So something like this. Then inside, it's a line. I don't know if they give an equation for this line, but you know what the equation is, right? It's y equals
1. X.
Okay, x. Then they give you some curve like this. And I don't know, it depends on WebAssign. I don't know what WebAssign puts here, but at least what I have, it's y equals 4th root of x. They may put square root of x, okay? I don't know. This is 4th. Sorry, kind of small, but this is 4th root of x. So this is the picture that they have, but also they name the regions. Like, for example, this triangle over here, they call R sub 1, so the region. The one that outside, almost like triangle, but with this curve, but actually the top one, okay? They call R sub 2 as the region. And this piece inside, they call R sub 3. So anybody got to this point looking at it, or are you still working on the other things? Okay, if you're being quiet, I'm getting the message, okay? All right. So this is the picture, okay, for every problem. And there's like a set of problems that relate to this. So let's put number 6, and here's the question. They're saying this: take region 3. So find region 3 and rotate this region about AB. So for me, when I look at this picture, I'm going to throw away anything extra and just only work with this region, so I have to redraw the picture. So this will be, so first of all, if it says AB, what's the equation of AB?
X equals 1.
X equals 1. So my axis of rotation will be x equals 1. So I'll be rotating this about the x equals 1. Okay? And then I will have this piece that I have to rotate. So this is the piece that I'm rotating. So now I'm going to pause for a second. I'm going to ask you dy or dx?
dy.
dy, right? Okay? So we have this dy. And then, again, if you look at my picture here, I'm going to probably right now solve everything for x, just to make sure everything is ready. So the line is just y, x equals y. I'm flipping this, okay? And then I have what? 4th root of x. So my x is what?
Y to the 4th.
Y to the 4th. Okay, it's just a little prep. You can do this later, but I just wanted to have this. So now I'm going to rotate this, and I will get something like this, right? And then when I slice this, so my cross-section will get this. Well, it looks like what? Slicing. When I say slicing, I don't know what coming to my mind, but it's just like Fruit Ninja, right?
Looks kind of like Pac-Man.
Right? Slicing the things? Okay, I don't know. Always we're limited here to the way you can slice. You know, when you play a game, you're just slicing everywhere in any direction, but here we're just going to do this. So the same thing that we had before. Do we have disc or washer?
Washer.
We'll get a washer, right? Now, but don't forget, when we go to large radius, you always go from axis of rotation to the original picture, right? So that means I'll go from my axis of rotation from this point right here to this one. This will be my outside radius, right? From here to here. So what's the outside radius? From here to right here. So what do we get?
1 minus y to the 4th.
1 minus y to the 4th. You see this? Can you see 1 minus y to the 4th? I just want to make sure you have no problems here. So then radius small, that's from here to this point, right? From here to here, will be what?
1 minus y.
1 minus y. Well, and we got those. Now just we have to set up a of y. So a of y, first area of the largest circle, again the one that's hidden kind of the disc and washer here inside. Okay, so we have pi 1 minus y to the 4th quantity squared. That's the area of the larger one. Minus pi 1 minus y quantity squared. That's the area for the smaller one. And when we subtract, we get just what we need. So volume, pi goes outside. Integral from what to what?
0 to 1.
From 0 to 1. That's right. Again, on what? Well, actually, I have to go up. Sorry, I went to the right. It's up because of dy, right? So from 0 to 1, and then we'll have this 1 minus y to the 4th quantity squared minus 1 minus y quantity squared dy. So we have this, and then just quickly let's go with this because I still want to have one more problem done. So integral from 0 to 1, and we have 1 minus 2y to the 4th plus y to the 8th. Right, opening the parentheses. Please do algebra right. No here creations. distributing 2 inside. Now you do a FOIL here. And then we have 1 plus, right? 2y and what? Minus, right? Yes, no? Minus 1. Y squared. Okay. So from 0 to 1, combining like terms, y to the 8th, we'll keep it first because it's positive, and the larger one, let's say, then we'll have minus 2y to the 4th, minus y squared, plus what? The left. 2y, good, and dy. Okay, easy to get our antiderivative here, so y to the 9th over 9, minus 2y to the 5th over 5, minus y cubed over 3, plus what?
Y squared.
Y squared, thank you. Okay, from 0 to 1. Alright, so we have this 0. We have the 0. That's nice to have it. And then we're going to plug this in. So we get pi. Then we have 1 over 9 minus 2 over 5 minus 1 over 3 plus 1 minus 0, right? So as the result, what we're getting? All right, what do we have?
Seventeen over 45.
And don't forget that pi, right?
Yeah.
And that's the answer. So did you get the idea? Yes, no? As a, what we're doing here. Okay, so all of these were fairly easy.
Can I get all
It was
custodians
not
to the
that
break room,
complicated,
please?
but
All
I want you
custodians
to
to the
look
break
at the
room.
end right now. There's one problem, and we will be working with this problem today and also tomorrow. Same problem, but what's going to happen, I'll show you different methods. So right now, we're just working with what we have right now, okay? So this will be example number 7. Let's say I have this. I have x, y equals 1. Then we have y equals 0. Then we have x equals 1, x equals 2. So these curves will enclose the area that I have to rotate. These 4 curves. And how we rotate this, about x equals -1. Now, there are not as many things I can graph here because x equals 1 is the vertical line, x equals 2 also vertical line, y equals 0, I know what that is, and I'm not going to see this on the graph because y equals 0 is what? X-axis, right? The other thing that I'm dealing is x, y equals 1, right? Now, this is implicit form. Can you make it explicit? So what is this?
Y equals 1 over x.
Y equals 1 over x, right? Do you see what we're saying? Implicit, remember mixing x and y together. Now we split this. Now it's just something that we've seen before many times. So this is what we have. All right, so before even doing anything, what do we have, dx or dy?
dy.
So we have dy, right? We have dy. All right, we'll come back to this, but now I have to sketch the graph. Now, you know how y equals 1 over x looks like, right? Do you know? Remember? Sort of? Well, I can put this into calculator, that's not the problem. Now, overall, if I put a little sketch here, somewhere on the top that you can see it, so it looks like this, right? This is your y equals 1 over x. But when I start thinking about everything else that I have, I'm not going to do anything with the bottom piece. Can you see that? Because you have to deal with what? Y equals 0. That's your x-axis, right? Then you have x equals 1. Then you have what? X equals 2. So everything that I'm dealing with is only sitting in the first quadrant. So I'm going to ignore this whole thing. Now remember, this is the sketch. So I have only one piece over here. Then I have x equals 1. then I have x equals 2, and then I have y equals 0. So overall, I'm going to make this a little bit thicker, okay, when I put the lines, that you can see the area or region that we're working. This is the piece that you're going to rotate. Do you understand? So this is the piece that you're going to rotate. And rotation goes about x equals -1. So x equals -1. That's the axis of rotation that we have. All right? Axis of rotation. And then I have to be very careful if I want to do this right, because I need to know how many units from the axis of rotation I have. So this is what I will get here. Now remember, this is just a sketch, so I'm not saying this is the best picture that I can get here. But anyway, this is what I get. Do you understand? So you take this piece and start rotating it. Now, I'm going to go faster here. I'm not going to ask too many questions. Normally, this is a good place to start asking questions, but I don't have that much time. Where the difficulty comes in here is the problem here with the integral itself. It's actually not one integral. We have two integrals. Why do we have two integrals? Well, take a look at our disks. Not disks, but what? Washers. If I'm somewhere over here, let's say, so my outside will be from here to here, yes, no? And inside will be from here to right here, right? But what if I'm over here? Then my outside will be to this curve, right? You see what I'm saying? And inside still will be to this. So what's happening, we're splitting integral with kind of the same idea as we have for area between the curves. Because my radiuses will be different, not like we had before all the time to one curve, you understand? So what's happening right here, I have to split this like this. Okay, why I'm splitting this over this point over here? Because of the radius, specifically for the outside. Because again, if I'm working with here, I'll go to 2 and then I'll go to 1, right? But when I'm somewhere over here, I have to go to the curve and then I have to go to 1. Do you understand that? So basically what we're doing here, we're going to separate this. So this nice, beautiful cylinder kind of flat thing will be right here on the bottom, and then this kind of curved piece will be on the top. Do you understand that? Okay, so overall, I don't know if I can do this nice. Okay, sorry guys. But you have something like this sitting on the bottom. Okay, something like this sitting on the bottom, and you have this inside piece. But also, you still have that little top piece, and that little top piece is going to look like this. You understand that? If we do the 3D, right? And specifically, the top piece will be kind of like over here. The hole is right here. Do you understand what I'm saying? So that's why we have two integrals right here, okay? We have two integrals. So I need to know where to split them. And this point over here, well, this one we know it's 1. Okay, we know this point is 1. But what do we get over here? I should say 1 is over here. What do we get right here?
Where they intersect.
Right, so where's that? Well, you can easily find it, right, if you put 2 inside. So this will be what? 1 over 2, and this is 1. So one more time, do you know where to get 1 over 2? This is the curve, right? And you know at 2 you will have this kind of division. So if you put 2 inside, you get 1 over 2. So you will have now two integrals. You'll have integral from 0 to 1/2, and you will have integral from 1/2 to 1. From 0 to 1/2, there will be one integral. We'll define this piece. And then from 1/2 to 1, that will define the top piece. All right? So let's see how far we'll go. Maybe we'll not do the problem like finishing to the end, but at least maybe we'll set out the problem. So what I'm doing right now, let's talk about this. Right now, I'm working with the top piece or the bottom, kind of doesn't make a difference, but let's talk about the top, because I did this in every class. I just wanted to be consistent. So I'm looking for the radius, larger radius of 1. You see, I'm getting so many subs here, okay? But radius of the larger radius for the first, meaning the top. So that's what? From here to right here. No, actually, I'm wrong. From axis of rotation, right? Up to this. So what will be the distance from here to right here? We kind of already had this before, right? This will be 1, right? And then what?
Plus 1 over x.
Right. Where students make mistake here, for some reason they're saying 2 plus. It's not 2, it's what? 1 plus what? The curve.
Could be 2 minus, couldn't it?
No.
No.
No. You have 1 and then remember, every time, this is going to be 1 and 2 and then curve. Because the distance to the curve always will be from what? Y-axis or what? X-axis. Do you understand what I'm saying? So it's not 2, it's 1 plus. So radius will be 1 plus 1 over y. And I don't know why I put parentheses. Okay, sorry guys, I don't want to get rid of them because it will be not very nice. Do you understand it? 1 plus to the curve. The smaller radius of the first one will be what? From here, let's pay attention. I know you know probably, but from here to right here. So what will be the radius here? That will be 2. 1 and 1, right? That will be 2. So you get 2. So that means the area, first one for this, the area for that one, will be what? Pi, right, what? 1 plus 1 over y quantity squared. Minus what?
4 pi.
Pi, yeah, you're right. I'm just going to keep it with the squares that we can see, but you're right. So that will be set up for the first piece, the one that sits on the top. Okay, that's a cross section of that piece, the one that sits on the top. Now we'll be talking about larger area of the second one, which is where? On the bottom. So what's the distance from here to right here?
3.
It'll be 1 plus 2, right? We'll get 3. So you get 3. And then radius for the smaller one on the bottom, again this will be 2, will be from here to right here. That still is what? No, I said still meaning what? 2, because it's the same, right? So we'll get 2. So then area of the second piece will be,
Pi minus 4 pi.
okay, but again, remember I'm going slow, you're too fast. But this is what we have. Do you understand it? So let's just finish this and we'll be done. So I'm not going to solve this, but let's set up the whole thing. So now my volume. Remember we said, I shouldn't take picture away because I need it. Remember we said we have what? 2 integrals. 2 integrals. So let's talk about the top piece. So the top piece, pi can go outside. This is our pi right here. Pi goes outside. You have integral, but what do you have? From what to what? 1/2 to 1. That's right. So I'm trying to fit this that you can still see the picture. So from 1/2 to 1. Remember, from 1/2 to 1. From here to right here. That's what we're talking about. And what do we have here? We have 1 plus 1 over y quantity squared and minus 4 dy. So that's the first integral, the top volume. And the second one we're going to add will be, let's pull out pi again, and will be integral from 0 to 1 over 2. Do you understand that? 0 to 1 over 2, and that's this. Well, that's easy to calculate. 9 minus what? 4, right? 9 minus 4 will have 5 dy. So that's our setup. Now, I'll give you the answer here, okay? I'll give you the answer. I don't know if you can see here, but you're going to have natural log here. Can you see where you will get natural log?
Yeah.
When you open parentheses right here, right, you will get 2 over what? 2 over y, and that's where a natural log will come in. Why I said this because I don't want you to be surprised, like, where are we getting this natural log? But this is the answer to this problem. So even right here, with this volume concept, you still may get 2 integrals. So that's why we have to wait till tomorrow to see how we can get rid of this. Okay? And I'm not talking about something like we did with the areas. Okay? Like we flip the picture. Okay? I'm not talking really 100%. Like flipping the picture and still doing the same. It's not the same. It's a completely new method that we're going to learn how to find volumes. But in that method will eliminate the 2 integrals. We'll have only 1. Okay, so that's tomorrow. All right, so, well, I'll see you tomorrow. The other thing, I'll give you a little gift, huh? These people will not hear me, but I have a gift for you. Not candy, sir. Not turkey. What I'm going to do, I'll take section 6.1 and sections 6.2 and 6.2, so two of those, and I'll move them till next Thursday. Not Thursday, but what? Tuesday. So basically, tomorrow will be what? I think 5, 3, 5, 2, 5, 4, 5, 4, 5, 5, something like this, right? But chapter 6, 6.1, 6.2 will be due next Tuesday. All right?
That is good because I did not have time to get all those done.
Well, and I understand that, but this is your Black Friday.
Yeah.
Okay? All right, well, I'll see you tomorrow.